Hello students, welcome to your favorite knowledge planet powered by PW. I am Tanya and yes, we are going to have the ultimate revision of your chapter motion. So this chapter is over. Certainly in today's class I will be talking about each and every topic, that too in detail, and we are going to summarize everything all together. So yes, you should have paper and pencil next to you so that you can note down the important points. And without any further ado, let's start with the first topic, that is nothing but your motion. So as the chapter name is there, motion. So everyone, when we hear this term, we say okay, change of position with time. But here we tend to forget one thing. What is that? Point of view or the reference point, certainly over here. So yes, when we talk about motion, it is nothing but change of position with the time and with the point of view, of course. So over here, have a look. There is a boy. Okay, this boy is trying to observe a car. Have a look over here. The car is changing its position from A to B. Right? Now you are going to say, yes, the car is in motion. The boy can observe it, and for the boy, the car is in motion. Right? Now let us take one more example. So yes, we are going on a picnic and I am sitting just next to you. Yeah, the whole bus is moving. Now in this particular scenario, when I am sitting just next to you, so what is happening? The whole bus is moving. Okay, let's take up the case. The moment you are going to ask this question to me, that ma'am, whether you are moving or not, certainly I will say, kids, you tell me. I am moving to you. Do you think that I am moving for you? So you are going to say, no ma'am, you are not moving because you are just sitting next to me. You are not changing your position with the time. Okay, so for all of you, when you can see me not changing my position with time, so yes, for you, I am not moving. Okay, but now as the bus is moving and you are going to ask the same question to a vendor who is standing outside, let's say a vendor who is standing outside, and you are asking the same question to that vendor, what he will say? Yes, you are moving. I can see you. I can observe you changing your position with time. For me, you are in motion. So everyone, when we talk about motion, certainly we have to talk about the point of view or to whom we are asking the question to. That matters a lot. And yes, over there, the answer can be contradictory. Now, let us take one more case. So, all of you, right now, I am nothing but a whole body. Okay, don't consider my mouth, my eyes, my head nodding or my hands moving. Yeah, certainly me as a whole body, for all of you, I am moving. No, right? Why so? Right now, okay, not like this, right? Certainly I am moving, but yes, right now, I am moving. No, why so? Because you can see me there at a particular place, not changing my position with time. Yeah, but there is someone who will say, no, Tanya, you are moving. Who's that? The astronaut there in the space. Yeah, why so? Because yes, I am a part of the earth, and for him, I am changing my position with time. With earth, I am changing my position with time. For him, yes, he can observe me changing my position with time. So he will say, I am moving. Okay everyone, now coming back to the definition, what exactly motion is? Motion is defined as change of position of an object. Okay, yes, change of position of an object with respect to time, certainly we all know that. But here, point of view matters a lot. So when you are going to use this term point of view, certainly that matters a lot. So motion, simple, change of position with time, and the point of view matters a lot. Now the opposite of motion will be nothing but rest. Over here, simple, time is changing, position not changing, and the point of view is also there. He is also agreeing on to it. So everyone have a look. When we say an object is said to be at rest, if it does not change its position with time and the point of view, have a look on the boy, right? He can see and he can observe that, okay, time is changing, but certainly, the position is not changing. Yeah, from A to A only. So you are going to call this body as stationary body, stationary object, object at rest, object not moving. Okay everyone, pretty much simple, motion and rest, very basic we are talking about. Now we all are surrounded by some quantities. Okay, so we are going to talk about some quantities everyone. So anything that that we can measure is a physical quantity. Okay, so if I talk about physical quantity will be anything that we can measure. Yeah, anything that we can measure. You can measure length. Yeah, you can measure time. You can measure temperature. So yes, all these are physical quantity, anything that we can measure. In physical quantity, we have divided these physical quantity among two categories. So first one will be scalar. Yeah, first type of physical quantity. The second one will be vector. Okay, one by one we are going to have a word on them. So yes, scalar quantity is nothing but a physical quantity, we can measure it. But in scalar quantity, we require only two things. What are they? Unit and numerical value. See, let us take one example. Let us say that, okay, my body temperature is 37 degrees Celsius. Okay, my body temperature is 37 degrees Celsius. Yeah, over here, number and unit. These two things are enough to share that, okay, this is my body temperature. Yeah, I need not say that, okay, 37 degrees Celsius in north. Okay, so over here, direction is not playing any role. Similar way, if I will tell you that, okay, the length of this pencil is 15 centimeter, you are going to say, okay, ma'am, 15 centimeter length. I am not specifying that 15 centimeter in south, in north, in east. Okay, so in scalar quantity, we are not giving any importance to direction. We are only sticking up with unit and the numerical value. Mass, 5 kg potato. You are not going to say 5 kg potato, 5 kg potato in north. Yeah, 5 kg in north. Yeah, so yes, direction is not at all important. These are the quantity. They only require magnitude, strength. Right? Numerical value and the unit, that is enough. Yeah, we don't require direction at all, but there are some physical quantities that require direction. What are they? So everyone, when we talk about physical quantity that require direction, for example, force. So if I will ask you that, okay, there is a box and push this box with 5 Newton of force. You are going to ask me, no, where should I push the box? So yes, when we talk about direction and the quantities that require direction, we talk about vector quantity. Vector quantity, they are the one, yes, there will be a unit, there will be a numerical value, but there will be direction also. So whenever you are talking about force, whenever you are talking about velocity, whenever you are talking about acceleration, weight, displacement, you need to be specific with the direction. Without direction, there is no point of talking about vector quantity. Okay, a box is there. I am telling you, push the box and 4 Newton of force you have to apply. Won't you ask me, where should I push the box? Right, left, top, bottom, north, south? Yeah, so without this direction, you cannot complete your task. Similar way, without the direction, vector quantities information is incomplete. Okay, I am saying that I am talking about velocity. So if I am saying velocity 5 meter per second, I need to add the direction, that is in north. This is velocity. Okay, 5 meter per second, then you are talking about speed only, no difference. Yeah, as we are through with scalar and vector quantity, let's have a look on distance and displacement, and the things will be more clear. So when we talk about distance, everyone, distance is the total path covered. Okay, and displacement will be shortest path. Now, remember one thing, if there are two places, right, and you have to reach from one place to the other, the shortest path between the two will be a straight line, always. Okay, so keep this thing in your head that whenever you talk about shortest path, then of course, the shortest path can be gained and can be found by joining them through a single line. Okay, now talking about distance, everyone, distance is the total path covered. Now let me take my example only. I am standing at place A. Okay, now I am moving to place B. Yeah, I covered 2 meter. Right? Now I back to A. Now I am covering again 2 meter, no? Yeah. So my total distance will be 4 meter. Okay, the total path covered by the body, that will be your distance. Yeah, it doesn't matter where you are going, right, left, north, south, doesn't matter. Yes, the total path covered by the body will be your distance. Okay, now if I will ask you what is the SI unit, you will say SI unit will be meter. And distance can never be negative, certainly, no? You cannot say that, okay, negative distance we have moved along. Yeah? So, distance positive. Moreover, no direction is needed. So, distance will be, yes, a scalar quantity. Okay? Yeah? This is normal about distance. Now let's have a word on something called as displacement. When we talk about displacement, I am telling you the shortest path. Yeah, in a displacement, as we are talking about the shortest path, of course over here direction matters a lot. So yes, we are going to specify that if I will take up the same example, I am moving from A to B, right, then B back to A. My initial position, my final position, they are the same. Shortest path over here will be 0. Okay, so when we talk about displacement, keep two things with you, that it is the shortest path, and if the final and the initial position are same, then of course over here displacement comes out to be 0. Okay, displacement requires direction. Displacement will be nothing but a vector quantity. Moreover, the SI unit is nothing but meter. Yeah, and whenever you will specify regarding displacement, right, you will say 4 meter in east. You have to specify direction, better way. Yeah, although we don't do that, but yes, it is better that we make this a practice from starting only. Okay, now coming back over here, yes, displacement can be 0. I showed you displacement can be positive and negative. So certainly over here displacement can be 0 also. Yeah, when the final and initial position, they are the same. Yes, over there displacement will be 0. Okay, and when you are going to talk about displacement, nothing but you need to see the shortest path. If the shortest path is not given to you, draw a straight line between the initial and the final position. You will get your displacement. Okay, now taking up this information, we are going to talk about something called as our speed. So everyone, when we talk about speed, speed is nothing but how fast or how slow an object is moving. Right? So if I am telling you that, okay, I am moving with the 4 meter per second speed, right? So I am specifying that this much fast I am going. For speed, you require two things, distance and time. And for that, of course, everyone, there is a trick to remember it. So the trick for speed, distance and time will be nothing but draw a triangle divided into 3 parts. Okay, now simple STD call, certainly we used to do so. Yeah, STD. Now, whichever quantity you have to find, you just need to hide that portion. See, I want to find out distance. So what I will do, I will hide the distance portion. What is remaining in the triangle? Speed and time. So distance is nothing but speed into time. Okay, let's do it with one more, right? Have a look on the time. No, hide the time portion. So, if I need to find out time, then the formula will be distance upon speed. Time is nothing but distance upon speed. Okay, similar way, speed is nothing but distance upon time. Now, guess how fast or how slow my body is moving irrespective of the direction. Certainly, we will say speed is nothing but a scalar quantity. And the SI unit of speed will be nothing but meter per second. All of you, this is the biggest confusion that we encounter. We say it's kilometer per hour. No, kilometer per hour is the other unit that we use. The initial, the static and the standard one would be nothing but meter per second. SI unit, meter per second. Okay, now as we are talking about speed, right, so certainly we need to have a look on types of speed. There are basically 3 types of speed: uniform, non-uniform and average. Yeah, as the term suggests everyone, uniform speed, non-uniform speed, average speed. Yes, uniformity, something will remain same, something will vary, and average in all, certainly we say, no, the average of a lot of things. Yeah, so let's talk about the first one, that is your uniform speed. We are going to quickly talk about it. Take up the example and then we are going to understand. Have a look. Now, there is a car moving from O to A to B, B to C and C to D. Okay, from O to A, if I need to find out the speed, everyone, it will be 10 by 10. Distance is given, time is given. So, speed will be 1 meter per second. Similar way, from A to B, distance is given to us, time is also given to us, speed will be 1 meter per second. Again 1 meter per second. Again 1 meter per second. Yeah, so in all these intervals, when we are seeing and when we are talking about the speed, yes, the speed is remaining uniform. So uniform speed will be when an object travels equal distance in equal interval of time, certainly throughout its motion we are going to say the speed is remaining uniform. No change in the speed is coming up. Okay, so uniform speed, everyone, equal distance covered in equal interval of time. Equal distances are covered by my car or my object. Yeah, now taking this thing only forward, if I say one thing is uniform, one thing is remaining same, the opposite will be non-uniform. So, non-uniform, everyone have a look on the example only. Now there is a change. My car is moving unequal distance in equal interval of time. Okay, if I will find out the speed in the first case, it will come out to be 10 by 10, that is 1 meter per second. Speed, distance, speed is nothing but distance by time. Yeah, that is what I am doing over here. Similar way in the next one, have a look. Distance is 30 and time is 10. So speed will be distance by time 3 meter per second. Have a look. Distance again 20. So, speed is equal to distance upon time 2 meter per second. Now, everyone have a look. Speed is not uniform, not same. And moreover, unequal distances covered in equal interval of time. So, what you are going to say? When my body covers unequal distance in equal interval of time and throughout its motion this is taking place, the body is said to have non-uniform speed or variable speed. You can say varying speed, no? It is changing, right? Okay, pretty much easy. One is uniform, one is non-uniform, unequal distances in equal interval of time. Yeah, last one, let's quickly have a look. So, talking about average speed, we say when, yes, your car is moving and covering unequal distances and unequal interval of time certainly over there. Yeah, so what we do, we take out the average. Average speed of the body is nothing but the ratio of total distance by total time taken. Okay, if the motion of the object is non-uniform, then we calculate average speed. Everyone, when it will be non-uniform, then only you will calculate average speed. Okay, total distance by total time. The formula, total distance by total time. So, if the distance travelled is 4 meter in 1 hour, then 2 meter, sorry, second, let's say, take second only, okay? Okay, in 2 seconds. Yeah. And they are talking about the average speed. So, what you are going to do? Total distance by total time. Average speed will be 2 meter per second. Okay, total distance by total time. Yeah, now from here, we are going to talk about something called as velocity. Everyone, velocity in simple terms will be speed with direction. See, I am saying 4 meter per second. Yeah, you are through that. Okay, ma'am, this is speed. But if I am saying 4 meter per second in south, velocity. Okay. Moreover, if you want to understand this, then you can certainly say that okay, velocity is nothing but displacement by time. That is shortest distance by time. Okay, so over here, when we talk about velocity, it is nothing but, yes, speed in a particular direction, or you can say displacement by time. Moreover, you don't want to use the term displacement at all. You can say distance traveled by any body per unit time in a given direction. Direction should be important. Why so? Velocity is a vector quantity. Without direction, you are sharing half information regarding it. Okay, so yes, velocity requires direction. Formula, everyone, have a look on the triangle again. Same triangle we can use. Only thing is now it will be VTD. Yeah? STD, VTD, velocity, time, displacement, whichever quantity you have to find out, you just need to hide that portion. And look what is remaining in the triangle, you certainly will be able to get the rest of the quantity. So velocity is nothing but displacement by time, time is nothing but displacement by velocity, displacement is nothing but velocity into time. Okay, so till here clarity we have. Now if I say what is the SI unit, what is the SI unit of displacement? Meter. SI unit of time, second. So meter per second. Yeah, from the formula only, right? Meter per second. Right? Now, similar scenario, right? We are going to consider that yes, we have some types of speed, right? Of course, we are going to have some types of velocity also. Okay, we are surrounded by a lot of scenarios, right? So, of course, over here, velocities will also be different. I am traveling in a straight line with 4 meters per second. Certainly, I am talking about velocity. Yeah, so I can change the direction, either I can change my speed, so of course velocity will also change. So have a look on that. Let's start with the first case, that is nothing but your uniform velocity. Kids, when we talk about uniform velocity, have a look clearly over here. Equal distances in equal interval of time, moreover direction also same. Right, so over here pretty much simple, uniform velocity, velocity that means speed plus direction. So yes, for speed what I have to do, to keep the speed same, what I have to do, of course equal distance, equal time. Yes, a car is moving from city A to city B. Okay, covering 30 kilometer in every 0.5 hour, 0.5 hour, not changing the direction also. So if an object travels equal distance in a particular direction in equal interval of time, certainly it will have uniform velocity. Also constant velocity. Yeah, pretty much the same. Velocity not changing, no. Yeah, over here in every scenario you are going to say that okay, the direction is also same. Okay, equal distance, equal interval of time, direction also same. See, 1 meter per second, 1 meter per second, 1 meter per second. Yeah, I am just stating. Okay, or you have to break it down more. Okay, 1 meter in 1 second straight line, 1 meter 1 second straight line, 1 meter 1 second straight line, 1 meter 1 second straight line. Yeah, like that. Okay, now taking up this thing to non-uniform. Kids, non-uniform velocity. So, of course, variance is taking place. How can variance take place? Now think. How can variance take place? Variance can take place either the speed can change. Yeah, velocity is nothing but speed with direction, no. Now, there are three cases, right? Either I can change the speed. Yeah, then of course, change in velocity. Either I can change the direction. Then also change in velocity. Either I can change both. Then also change in velocity. Right? So when we talk about non-uniform velocity, it is not only one case. Yes, you can either change the speed or change the direction, or you can change both. Okay, you are there in a crowded road. Certainly your velocity, your speed will also change. Your direction will also change. Yeah, so what you are going to see, you are moving with non-uniform velocity. Okay, when we talk about moving in a circle, right? So of course over there direction is changing at every moment. Yeah, moreover, if I will change the speed also, non-uniform velocity taking place over there as well, keeping the speed same. Okay, so non-uniform velocity, the velocity of a body can be variable either due to change in magnitude, certainly we are saying speed, or change in direction, or both magnitude and direction. Okay, so in non-uniform velocity, you will say a body moves unequal distance in a particular direction with equal interval of time, or equal distance in equal interval of time with different direction. Yeah, so certainly have a look on the graph. This is how the graph looks like. Okay everyone, non-uniform velocity pretty much clear. Let's move this thing forward and let's talk about something called as acceleration. So everyone, there's a huge misconception we have that okay, acceleration is nothing but change of velocity by time taken. Half true. Why half true? Because when we talk about change of velocity by time taken, we are forgetting one thing, that is rate of change of velocity. Now, what do I mean over here? See, I am there in my car. Okay, my car is moving from 0 to 40 km per hour. Okay, that is the change happening in 1 hour. You are there on your cycle. You are moving from 0 to 10 km per hour in 1 hour. Okay, both are accelerating. Change in velocity, initial was 0, final is 40. Yeah, both are undergoing acceleration, but over here you have to specify, right? Quickest, have a look. In 1 hour, 40, 0 to 40. So yes, my acceleration is more. Getting me everyone? So over here what is happening? Change in velocity by time taken. Yes, the rate also matters, how quickly the change is taking place. So when you say change in velocity, final velocity minus initial velocity upon time. What is final velocity? When you stopped observing. Yeah, that will be final for you. When you started observing, that will be initial velocity for you. Okay, see, I am saying that okay, we tend to get confused now over here. We say that okay, the object is at rest and it started to move. When the object is at rest, initially it was 0. Yeah, when the brakes are applied, yeah, the body stopped. So over there final velocity came out to be 0. So you have to specific with the terms everyone. Yeah, V is nothing but final velocity. U is nothing but initial velocity. Okay. And final velocity when you stopped observing. Initial velocity when you started to observe. Moreover, velocity we are talking about, of course, it is a vector quantity, and certainly we will say that okay, acceleration is nothing but, you can in simple terms, so keep the things in simple terms, change of velocity by time taken, that is how quickly the change is arising. I am concerned with that as well. I am just not concerned that okay, change is taking place, but how quickly it is coming out. Now, when we talk about the unit over here, what is the SI unit of velocity? Although it is change in velocity. 5 rupee, I am taking out 2 rupee from it. It will remain rupee only, no? So, velocity from, subtracting from velocity, velocity. So, meter per second. SI unit of time, second. Meter per second square. That is the SI unit. Okay, without unit, if you are stating anything right, believe me, you are going to get the wrong answer. Yeah, your teacher is going to cut the mark. Yeah, you have to be clear. Okay, now taking this thing forward, when we talk about acceleration, of course, let us take up some examples over here. We are saying that, okay, over here, a car is starting off from traffic light or green signal, speed is changing. So, over here, what they are trying to say, initially the car was at 0. Now, it will have some velocity, let us say 5, and there will be a time taken. Okay, so over here what is happening? The speed is changing. As the speed is changing, of course, no, have a look, right? As the speed will change, yes, velocity will take place, of course. You know, non-uniform velocity you can certainly talk about, and in a specific time. So yes, acceleration. Okay, moreover, have a look. A car moving round at a bend at a constant speed, here direction of the motion is changing. So of course you can certainly say no, direction is varying. As the direction vary, what will happen? Non-uniform velocity, certainly the change in the velocity taking place. Okay, over a time. Yeah, acceleration. Okay, now taking this thing only to some types of acceleration, let's talk about uniform acceleration. Kids, in uniform acceleration, you have to be pretty much sure that, okay, over here, a body is traveling in a straight line. Okay, direction same, straight line. Okay. Now, its velocity increases by equal interval. Now, over here, you cannot say that, okay, we are going to keep the velocity same. Yeah, over here, velocity is increasing, but it is increasing by equal interval. Have a look. The car was initially at 0. Okay, now car is having velocity of 1 meter per second. This whole thing is happening in 1 second time. Okay, so if you will find out the acceleration, 1 minus 0 by 1, it will come out to be 1 meter per second square. Yeah, now let us take up this case. Over here, initial velocity will be 1. Final velocity is 2. Right? And time taken over here is 1. Yeah, so subtract and tell me acceleration come out to be 1 meter per second square. Okay, now certainly if I will tell you kids that, okay, there is a increase happening, although you can say that, ma'am, in this particular case, right, there is no sudden increase taking place. But if you are going to consider it with the initial one, yeah, if you consider like this, okay, so of course 0, final is 2, acceleration will be 2 minus 0 by 1, 2 meter per second square. So you can see that, okay, there is increase. Okay, equal amount of increase, 1, 2. Yeah, equal amount of increase is taking place there in the whole scenario. Okay, so when we talk about uniform acceleration, if its velocity changes, yeah, yes, it will change at a uniform rate. The motion of a freely falling body. Yeah, over there also, no, yeah, acceleration is taking place, but at a uniform rate. Okay, velocity, if its velocity changes, it should increase at a uniform rate. Okay, clear everyone? One thing is uniform, the opposite is going to be nothing but non-uniform. So when we talk about non-uniform acceleration, you can simply say that, okay, we say a body is there if its velocity increases by unequal amount. So yes, my velocity is changing. Have a look over here in the example only. Initially it was 0, final 1, accelerate in time 1 second, acceleration 1 meter per second square. Yeah, acceleration is final minus initial by time. Okay, now have a look over here. When we consider this scenario, velocity initially is 1, final is 5, time is 1. Now acceleration is 4 meter per second square. Okay, so when we certainly see and observe this scenario, yes, there is increase taking place, but it is unequal amount of increase that is taking place. It is not at a uniform rate. So we are going to say, yes, this condition is nothing but of non-uniform acceleration. Acceleration is happening, yeah, but at a non-uniform rate. It is not at a proper scenario. Yeah, sudden break, sudden increase, sudden change in the direction, of course that will lead to rate of change in the velocity, certainly acceleration at a non-uniform rate. Okay, now taking this thing up, we are going to talk about retardation. In simple terms, retardation is nothing but negative acceleration or deceleration, you can say. Over here, yes, your retardation is acceleration negative. But all of you, whenever they will talk about, okay, acceleration is minus 2 meter per second square, if they will tell you acceleration is minus 2 meter per second square, what is retardation? You will say retardation is 2 meter per second square. Why so? Because yes, retardation itself means it is negative. Okay, so yes, you are going to say 2 meter per second square directly. Yeah, how retardation takes place? Retardation will take place that when initial velocity is more than the final velocity. That means initial velocity is 20 meter per second. Final velocity comes out to be 10 meter per second. This is happening in the time span of 1 second. Yeah, so over here, find out the acceleration. 10 minus 20 by 1, that will give you minus 10 meter per second square. Okay? Yeah, so retardation is nothing but negative acceleration. We say that okay, if velocity is decreasing, right? Velocity is not increasing but it is decreasing. Yeah, now taking this thing up, and we are going to talk about our average velocity. Kids, when we talk about average velocity, we certainly say, okay, in simple terms, average velocity will be nothing but total displacement by total time. But there is one more formula for average velocity. We say average velocity is nothing but your u plus v by 2. Okay, initial velocity plus final velocity by 2. That is the other formula that we use. Why we are talking about this over here? See, when we talk about average velocity, right, it is displacement by time. Yeah, of course you can say, no, total displacement by total time, certainly. Yeah, so we are going to be using this scenario in the numericals also. Yes, when there will be some cases that you have to talk about. Okay, so let's take up this information and let's talk about our equations of motion. There are 3 equations of motion, and everyone, whenever we talk about these 3 equations of motion, yes, the body should have uniform acceleration. Okay, if there is increase in the velocity taking place at a uniform rate. Yeah, so in uniform acceleration only the 3 equations of motion will be held true. One by one we are going to talk about the 3 equations of motion, and yes, these equations of motion, they give a relationship between initial velocity, final velocity, time taken, acceleration and distance travelled by the body. Okay, now one by one we are going to talk about them. We are going to have a look on the derivation also. So everyone, the first equation of motion, v is equal to u plus at. How this came into picture? What is the formula for acceleration? Final velocity minus initial velocity by time. Okay, take time on the other side. What you are left? At is equals to v minus u. Now take the initial velocity on the left hand side. You got your first equation of motion, v is equals to u plus at. Over here, final velocity, acceleration, time and initial velocity, they are having a relationship. Okay, now second equation of motion. The second equation of motion is s is equals to ut plus half at square. For this, you require to have the average speed formula. What is the average speed formula? Oh, sorry, average velocity formula. Average velocity is equals to u plus v by 2. Okay, now break average velocity, s by t is equals to u plus v by 2. All of you in your second equation of motion, you have v. No, right, final velocity is not there, no. So I need to change this v, right? How? V is equals to u plus at. So in the place of v, can I use u plus at? By 2 s by t. Okay, now solve it. 2u plus at by 2s by t. Yeah, you will get s by t is equals to u plus half at. Take the t at the bottom of the left hand side, no, on the top. S is equals to ut plus half at square. Second equation of motion. Pretty much easy, right? Now taking the third equation of motion. V square is equals to u square plus 2as. So over here, again, average velocity. Average velocity s by t is equals to u plus v by 2. Okay, have a look. Do we have t over here in our second equation of motion? I don't require t, right? So s is equals to u plus v by 2 into t. This t need to remove. Acceleration is v minus u by t. Right? From the first equation of motion, value of t will be v minus u upon acceleration. Can I use that? Yeah, we are just going to use first or second equation of motion all together, right? Hand in hand. Okay, so now place the value u plus v by 2 v minus u by a s. Take 2 and a on the other side. 2as is equals to u plus v minus u. So a plus b into a minus b, maths formula, right? What you are going to get here? V square minus u square, that is nothing but 2as plus u square is equals to v square. Third equation of motion. Okay. Now as we are through with the derivation also, that how we need to derive the three equations of motion, now we are going to talk about our graphs. So everyone, when we talk about a graph, your graph will give you two information. What is that? Slope and area. Okay, now whenever you talk about slope, right, how you need to find out slope in a graph? In a graph, the slope will be found out by y by x, or you can say perpendicular by base. Okay, so either y component by x component or perpendicular by base, right? Yeah, perpendicular by base. Yeah. Moreover, area will be found out by the area under the curve. Whatever shape you are able to see, trapezium, rectangle, square, triangle, you just need to find out the area under the curve. Okay? Now, one thing is very, very important when we talk about slope, and when we talk about slope of a distance time graph. So slope of a distance time graph will give you nothing but speed. Okay? Slope of a velocity time graph will give you nothing but acceleration. Last thing, area of a velocity time graph will give you nothing but distance. Okay? Yeah, how we are going to use it, that we are going to talk about, but yes, this is the trick that you can remember. Displacement time graph slope will give you velocity. Okay? Although that thing, rarely comes, but yes, certainly if you want, yeah, of course, VT graph, displacement time graph slope will give you velocity. Okay, now taking this thing up, let's talk about distance time graph. So everyone, when we talk about distance time graph, right, have a look. First of all, slope of a distance time graph will give me speed, and area of a distance time graph will give me nothing. Okay? We don't talk about area of a distance time graph. So have a look. When a body is distance time graph, when a body is at rest, okay, when the body is having uniform speed, okay, and when the body is having non-uniform speed. Okay, and for this only you can say, for speed we say y by x or perpendicular by base. Yeah, right? Now this is all your distance time graph. When the body is not moving, certainly at, see, this is not changing, no, at rest, first case. Okay, uniform speed, slope, incline. Okay, third one will be non-uniform speed, you can see the curve. Okay, now speed time graph, or you can certainly say velocity time graph if you want to, but there is no as such difference, right? So speed time graph, constant speed, When there will be a constant speed, no? Okay, speed time graph, or you are comfortable with velocity time graph, you can say velocity time. Then it will be constant velocity only. Okay, next one. Uniform acceleration, non-uniform acceleration. So, uniform acceleration, non-uniform acceleration, uniform retardation, if you want to see, it will go just like this, okay? Retardation. Okay, now the slope of a speed time graph, velocity time graph, certainly it will give me acceleration. Okay, found out by P by B, perpendicular by base or Y by X. And area under the curve will give me distance, found out by area formulas. Okay? Yeah? And as the space is there, retardation, let me show you. Uniform retardation. You want, you can place it VT. Okay? It is pretty much okay. Yeah? Relatively we use these terms. That is why don't get confused in that. Yeah? Moving ahead. Now we are going to talk about the last thing, that is nothing but uniform circular motion. So everyone, when we talk about uniform circular motion, we are saying that okay, there is a body moving in a circular path, keeping the speed same. Then why uniform circular motion? As the speed is same, direction is changing at every point. Have a look, direction will change at every point. So you are going to say it is accelerating. Yeah, so we say that okay, when the earth is moving around the sun, certainly over there also uniform circular motion, because the path is okay elliptical as such. Yeah, we are going to take circular. Okay, so over there of course it is moving at every point, its direction changes. So when a body moves in a circular path, then its direction of the motion keeps on changing continuously. Since the velocity is continuous and we are taking the speed same, so of course therefore the motion along the path will be accelerated. Okay, so of course no, direction changing, right? So accelerated. Yeah, although you are going to keep the speed same. Okay everyone, now this was all your recap, and certainly use the formulas in your numericals, and the graphs also that I gave you, no, slope will give you speed, this will be used in your numerical only. So yes, I will be seeing you all soon. Certainly, thank you so much everyone, and I hope the things were clear. Thank you so much all of you.